Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.
Hey everyone, so today we wanted to talk a little bit about the importance of synchronizing to a calibrated time source. So part of your NIST 800-171 requirements are going to require that you do this on systems. Now largely this is going to be controlled by your IT teams who are going to either set your systems up to link up to the NIST servers, or they're going to set up their own time servers internally to your facility and synchronize your different workstations and computers inside of the facility to that time server that is synchronized to NIST. So for the most part, this should be handled by your IT team. I wanted to just show some tools we can use in LabVIEW for if this isn't done automatically, how in LabVIEW can you synchronize your computer to the NIST time servers? And then also, if we want to do like a calibration and basically show, hey, how close are we to the NIST time servers? How can you do that? So I've had requirements working on projects, especially like NADCAP requirements and stuff for different processes, where we've had to be able to show, hey, this system's time, the clock on this system is accurate to the NIST time servers within some amount of time. So this is a way that you can actually demonstrate that you are synchronized to the levels you require. So I have this VI here. And so basically we have this function that is getting the current time from the NIST time servers. Here I just have one IP address of a time server. There are many. So if you just Google NIST time servers, you'll find this website. This is the URL right here. But basically they have a list of all of these different time servers and their locations. So ideally you want to choose one closer to you. You have, depending on where you're located, it may be more or less possible. But yeah, find one that is nearby you. They are not always available. Sometimes these servers will go down. So if one is down, you can try a different one. But yeah, here's a link to find all of the names and the IP addresses. So once you've found the time server you want, now we're ready to get the NIST time. So let me show you how you can do that. So we're going to do this using TCP, so just the native LabVIEW TCP functions. So here we just have a TCP open, and we're going to connect to port 13, which is part of the NTP protocol, and then we're just passing in this IP address. Once we connect to that port at that IP address, it's going to respond with the time string for us. We don't have to request anything. It just, once you connect, it sends that string over to you. Here we're also getting the current system time, so we can kind of do a little comparison about, hey, the NTP time versus our current system time. We're just going to listen for 51 bytes. And then we've got a little bit of parsing here, so we can kind of break apart that time string and get it to the right format. So this NTP string, we're just going to output. I'll show you what that looks like. And these functions here are set up to format this date time string in the correct way that we can pass it into this kernel 32 DLL, so we can actually update our system clock. So I have this little true false here. That way you can either just read the NTP string if you don't want to actually update your clock, just check. Or you can set this as true and it will actually update your system clock. You can see here, we're just connecting to system32.dll, and there's a function in there called set system time. Really not a whole lot to it. And then we've got this system time parameter that we're writing to. The type I've just got set to adapt to type, and data format is handles by value. So that's where we're actually going to be inputting this 16-bit integer that represents our time. So this does most of the heavy work, right? This is going to connect to your time server, read the time back, and if you want it to, also update your system clock. So this is a way to force synchronization to a different time server. Now, if we go back to this VI, this one basically is just going to take this NTP string. So it's going to look something like this here. And everything in here represents something. So some of them are obvious, right? You've got like a date here, you got like a time here. Some of these other characters are health of the server. They indicate stuff about like daylight savings time, stuff like that. So yeah, and then this VI would be all that you actually need to break apart that string into its individual components that we need. And then we are converting that to a record and from there to a timestamp. So this is how we're going to get our timestamp from this string. And just a little bit of like cleanup on the startup side. Really not too complicated. And then, yeah. And then we're basically just converting these to floats and, you know, deciding which one's greater so we know which one to subtract from the other. You also could just do an absolute value. That works. And then just getting the time difference between both our system time and our NIST time. Now, there are some caveats to this because when we are getting the NIST time, there's no guaranteed timing in terms of how quickly this web or time server is going to respond to us. I mean, it's typically very fast, but there's network latency to consider, and depending on the server you're connecting to, how far away you are from it can slow it down. So take the numbers you get with kind of a grain of salt. That's not going to be 100% accurate. There are some better tools for time calibration out there. This works reasonably well to show that, you know, hey, we're, you know, within, you know, some amount of milliseconds of this, but it is influenced by basically the latency of getting this request. And, you know, LabVIEW, when it pulls this system time, this is what you're actually comparing against what's returned here. So there's, yeah, a little bit of difference you can have just from the kind of synchronizing when you're pulling your system time to when you're actually getting your NIST time. But yeah, that's basically it. So then we can basically just take this code, run it, and we get an NIST time and our system time. And we get the difference in terms of seconds. So like I said, there's a little bit of latency in there built into it. But if you want to show, hey, you know, we need to be, you know, calibrated to NIST time within, you know, some amount, you know, 2 seconds, 3 seconds, whatever that is, you know, this is a good way to just demonstrate that. And you could even run this multiple times and take like an average or something to try to factor out different, just outliers as a result of latency. And one thing to note is that NIST will rate limit you, so you can't just make a lot of requests very quickly. Eventually, they will just block you temporarily, so you can't make any more requests until enough time has passed by. So you can't just run this over and over and over again very quickly. You can run it a few times, and then you'll have to wait a minute, and then you can run it a few times. I don't remember what the exact limit is, but yeah, that would be how you can get a good calibrated time source and synchronize to a calibrated time source in LabVIEW. And this is Windows specific. As you saw, we were calling the kernel 32 DLL, so this is Windows specific. I am going to make a separate video where we walk through how you can do something like this on an RT target, like a Compact Rio. And there actually are better tools on Compact Rio for that than what we have here. So excited to get that up and ready. And don't forget to tune back in. Thank you.